I think that means we're live. Good morning. Welcome to the last day of Dreamforce. You made it all the way to the end. This might even be your last session. I don't know. You're probably very, very tired if you're anything like me. It's been a packed week, but it's been a really awesome week too. So we'll start with introductions. My name is Melissa Hansen. Community-wise, I'm a Salesforce MVP. I co-lead the Salesforce developer user group in Portland, Oregon, which is where I'm from. And I'm also on the steering committee of a group called Rad Women Code, where I develop a curriculum to teach advanced admins the basics of code over 10 weeks. I also have a day job. I'm the senior developer at a nonprofit organization called Stand for Children. We're a national nonprofit. We're medium-sized, but we have a really big vision, and big technology needs to match. So I do get to build a lot of really fun stuff on the platform. Most recently, we built kind of a standalone Lightning app that's public-facing, which was a big deal for us. And we host it on communities, and it's available for public school teachers across the country to deliver kindness-based curriculums in middle schools. So that was super fun. And a couple years ago, I built an integration between Salesforce and Heroku, which was basically like a homegrown Salesforce Connect. And I did it using the Streaming API, which was the first sort of event-driven style of development that I'd done, and it was really fun and really fast and really compelling. And so I was really excited to start to dig into platform events, but we'll talk more about that in a minute. That's probably plenty about me.
My name's Larry Latimer. I do work for Salesforce. I work in IT, one of the developers in checkout and quoting. I'm a co-founder of Forcelandia. So Forcelandia is a community event, a little smaller than this one, up in the Northwest. I also co-founded the Portland Salesforce Developer Group. I've spoken several times in the past here and at Snowforce and Force Academy, mainly on testing. So when I saw platform events, I got excited about how I could use that to make testing easier on the platform. So to start off, of course, our forward-looking statements. So make sure that any buying decisions you might make are based on products and services that are currently available. So what we're going to cover today, mainly, are the architecture, microservices, and microservices on the platform, and how platform events can help make those easier. Then we're going to go microservices and then platform events, and then we're going to go into some demos and how we used it in this situation. At the end, we're going to all do a demo together and review some code.
Beautiful. Okay, so before we jump into some architecture diagrams, just to kind of set context about what we're talking about, which is really comes down to building and integrating complex systems. That's why we're looking at different architectures, different approaches. We want to build systems that are delightful for our users, that are stable and easy to maintain for us developers, and that are easy to extend and build on, and that we can build upon quickly and as quickly as we need to. Last year I went to a lot of sessions on microservices, on event-driven development, and a little bit on Apache Kafka, and I got really excited, and I was like, this is really cool, but I wasn't super clear on how to implement that back in my own Salesforce implementation, because it's a little bit different. Larry and I are both primarily Salesforce developers. We integrate with other systems, but Salesforce is kind of our bread and butter and at the heart of everything we do. So we were talking along those lines, and we decided to build a little proof of concept just so that we could kind of learn, and that's what we're going to share back with all of you today. I'm going to go off my talk track just a little bit because it's been interesting all week to see how much is coming out around really event-driven and microservice architecture. Like if you were at the keynote yesterday and you watched Zane doing that amazing demo of all those integrations and all of the things that Salesforce is exposing so that you can start to hook into those events, like Lightning Data Services. If you're not familiar, that's just it's a part of the Lightning platform that lets you do CRUD operations without your own controllers. You're now getting live updates when those records are going to be updated anywhere else in the system. it's something that I see Salesforce do over and over. They go and they build in a certain way, and they build themselves the tools that they need, and then they start to expose it out to all of us. And that's really exciting. So if you get nothing else out of today's session, I would say going back and playing around with event-driven stuff, learning a little bit more about all the stuff that's coming out in Winter 19 especially, and implementing it, and having that mindset when you're looking ahead and architecting out your systems for the next few years is going to be really key, because they're clearly investing a lot in it, and it's an exciting area. Okay, so architectures. I like to just kind of make sure we're all on the same page, and you can get an idea of what I mean when I'm saying these terms. So monolithic architecture, what we're talking about is a system that has a shared database and a shared code base. We have a lot of tightly coupled services. We may have things split up a little bit by area of business. We may have some special kind of subsystems, but in general, everything is tightly coupled and part of this big system altogether. And this probably looks pretty familiar, because this is a lot what our Salesforce instances look like. I'm going to contrast that with microservice architecture in just a minute, but I want to talk about event-driven development, because I've said it several times now, and I just want to kind of talk about what I mean. So you'll see this illustration even a couple of times in this presentation, and probably all over the place, because it's a nice way to conceptualize what event-driven really means. So publish and subscribe, fire and forget, those are all terms we use. And it's really about a system that is pushing out an event into a stream. So something's happened, and it knows that downstream consumers might care about this, so I'm going to publish it into this channel. And you can have downstream consumers that are subscribing to this channel so that they can grab those events out. There's probably some bit of data payload that's part of it. And it's a really loosely coupled system. So the event producer does not know about, care about, or depend on which consumers are down the line. The consumers don't know about each other. They are entirely separated. So if we want to add new producers, if we want to add consumers, take them away, it doesn't affect the other parts of the system. And that's a really important part of understanding this. And lets us kind of talk about microservice architecture. So I've got sort of the same systems that I had in that monolithic drawing here, but these are now organized into microservices. So each shaded area is the microservice. It's got its own database. It's got its own code base. It's got its own APIs. And all of these are able to publish and subscribe to this event bus. And this is nice because these are loosely coupled now. The complexity may be hidden within those REST APIs. They have independent databases and code bases. But why would we want to architect like this? Because now we've got more systems, more integrations, more problems. But there's some really compelling benefits to developing in this way. And a big one is interchangeability. Like, we can swap out systems much more easily with this style. Like, if we, I've got an inventory management system sort of up here. If that technology stack isn't working for us anymore, if we need to swap out the tools, we can do that without impacting any of these other systems. We can swap out the underlying complexity, and that REST API can stay there, and what we're publishing and subscribing to the event bus can stay there. And it's a really nice swap out that we can do without having to impact all of our other systems, and it lets us move more quickly. And another way we can move more quickly is if you have a large system, this also lets you split up your development teams. When you have one big shared code base, it can be difficult to have a whole bunch of developers all in that same code base and trying to reconcile those differences and trying to merge all those changes together. It slows you down. So this way you can have focused teams on their particular piece of the stack. And let's see, I think I wanted to call out one other thing. Oh, SFDX. So if you've been playing with SFDX, I've been spending a lot of time on that lately, and it's a great object lesson in why you want to have a nice separation of concerns and a microservice approach, because it's a great tool set, and it lets you have a really nice modern development flow. But if you have, like I have, kind of a happy soup architecture where all of your code is together, some things are spread out, but there's a lot of sharing going on. And so trying to decompose that into non-overlapping packages so that you can start to take advantage of that flow is a huge challenge. If you're doing something greenfield, if you're an ISV, that may be a little bit easier. But as I've been going through that process, I've been thinking about, oh my gosh, I wish I could go back in time and just tell myself, interfaces, split those things out. You'll thank me later. But I can't do that. We can't look back. We're looking forward. But So I'm going to take us back to this monolithic architecture slide, which is where I started. So how do we utilize a microservice approach along with this monolith? And I think the first thing to call out is that we already have some tools to take a microservice approach here. I've called out these systems separately: opportunity management, order processing, inventory management, because we've done a nice separation of concerns. We've packed all this business logic into its own little container. We're using interface as well. That's a way to take a microservice approach without actually being able to split them out. And it's not a true microservice because we still have a shared code base. We still have a shared database. There's no way to get rid of that, but we do have tools for these things. Another existing pattern, like if you've done Lightning development, you can think of a component as basically a microservice. It's got interfaces that are defined by the methods and the attributes that you can set. It has minimal dependencies. It has its own functionality that it's delivering, and it's loosely coupled with the other ones, and you can use them like building blocks to make more complex systems. In the Winter 19 release, we're getting a new Apex interface, system.callable. That's going to let you have much looser coupling between classes all over the system that want to call into each other. And we've got some resources on that in the slide at the end of the deck. So this is kind of where we were up until Salesforce introduced platform events. And with platform events, now we're able to have an extra step in that sort of spectrum from monolithic to microservice. Because we have this event bus, it's inside Salesforce, and we have external systems and internal systems all writing to and reading from the same event bus. And this is really cool. We've got, we can have an external system that's firing into this event bus. The consumer is inside. It doesn't matter where that event was fired from. It could be from an external system, internal system. It doesn't matter, and it's not transparent. So Salesforce gives you a lot of hooks to do this declaratively as well. So when I thought about, okay, what kind of demo are we going to build? I want to have an external system sending platform messages in. And then I can actually have declarative tools pick up that platform event and do a whole bunch of functionality and have all that complexity wrapped up in whatever little service I'm building, and all the other systems don't need to know about it. So I can have a pretty complex integration from an external system that is handled completely declaratively. And you'll see when we get into our demo, we don't have any triggers as part of this. We have some lightweight code, but a lot of this is handled completely declaratively, and that's really compelling. Okay. I guess the last thing, I think it illustrates the kind of mindset you want to have with microservices and thinking about them as building blocks. How can I boil this down to the simplest amount of, or the simplest bit of functionality that I'm trying to achieve that makes sense to wrap up, and then build these things together to get to your complexity and to get to your bigger systems. That was a lot of abstraction, so I think I'm going to throw it over to Larry so we can actually dig into some more specifics.
So let's look at how we implement platform events. So what are platform events? What is an event bus? And how has Salesforce implemented those tools? Platform events are asynchronous and one-directional. The event bus processes the events in the order in which they're received. First in, first out. Melissa mentioned that. Because the publisher and the subscriber are executing in different transactional contexts, the publisher has no knowledge of who or what actually is consuming the event. So platform events are fire and forget. However, the consumer does have some knowledge of the publisher and what it's providing through the payload that it's passing through. However, so some of the benefits, the ability to add and remove processes without refactoring. So you plug and play different services. Ideally, those services are fully decoupled. Very similar to what we're doing in Lightning. So when you think of Lightning and Lightning pages, you're grabbing components and putting them all together. So microservices is supposed to work the same way. Also, the ability to refactor, again, and reducing the dependency between those processes. So if those processes are truly isolated, it makes testing of those processes easier. So this is what made me excited about platform events is you can actually start separating things, creating those microservices, and controlling the inputs and outputs of those microservices, making functional and unit testing a lot simpler. So lastly, platform events can be consumed by multiple processes, internal and external to the system. How do we create platform events? It's very much like creating a normal custom object. So you create the object, you add fields, and those fields are later going to be represented in the payload as part of what's the consumer is going to receive. So we'll see a little bit of that later. So publishing, how does it happen? Some predefined action occurs causing the event to be published from some source such as Apex, Flow, or Process Builder, or maybe an API like we mentioned. The event is added to the event bus, and subscribers are monitoring and listening for those events to occur, and then doing something with it. And keep in mind, again, if there's any failure through the process, there's no feedback back. And I'll be reiterating that several times because that's pretty important. There is also, if there is a failure, a way to replay the event for up to 24 hours using something like Comet D. So events can be published, like I said, through Apex using a publish method of the event bus class. And when that's done, you're usually passing in the parameters, or you will be passing in the parameters that you've defined when you created the custom event as those fields. Also, as an Apex developer, you can subscribe to the events through the after insert of that event. So the event is very much like inserting a record. So you insert the event, and there's an after insert of that event that you can hook into as a developer. Once that process is complete, just like with a DML insert, you can examine those results and see if there's any failures in that. And if there is a failure in that process, you can repeat that process up to 9 times. So that's a benefit and a way to hook into that and maybe report any failures that might happen. Sorry, I started to repeat myself. So using APIs, we have the ability to, using APIs, external systems can easily fire off events to the org, either with SOAP or REST. And external systems such as, also as external systems such as Heroku can subscribe or even publish events. And this is becoming a lot more easier as you saw with Zane's presentation. Comet D is used in Lightning and Visualforce currently to make all that happen, as well as it says in Heroku, but that's changing with some of the new releases. So how is this done? So using REST APIs, you can put, using this endpoint, you can put and pass in those parameters. Those parameters, again, are the field values, the fields that you created when you created the event. So this is the way to pass in those values for the consumer later on. And then once that is received and saved, it returns the ID of the record and any passes or failures. So programmatically, or using Comet D, and I'll show you an example of this later, you would link into the event, and the event's defined with __E. And the payload that you would receive is very similar to what you see here. The fields that were defined, as well as some extra information like a replay ID. And again, I'll show you this later, but Comet D is one of the ways that you would use, you would use it in this scenario as well as for any replays. So Comet D, and Comet D is currently saved as a static resource whenever you use it. We also, and this comes into the microservices realm, you have access to events and Apex through Process Builder as well as Flow. And the idea here is you're able to create these processes and put these blocks together. And this is all initiated in our scenario through an event. So these are building blocks that you can manage complex business processes with declarative tools just like this. So it doesn't take a developer to create all these complex business processes. Developer may be creating those microservices that you're using, but putting it together could be just an admin adding or manipulating some of these blocks. All right. Of course, there's going to be limits. So here's some of the constraints that we're limited to. So currently, these are the standard limits I got this from winter 19. I highlighted some of the important ones, or the ones I thought were important. But if you might be approaching or exceeding these limits, there are other high volume options, such as currently there's a pilot on winter 19 for a high volume version. So high volume allows you to have 250,000 versus the 100K that's currently available with the standard. And for really, really high volumes, that's when you would switch over to something like Kafka, Apache Kafka. So considerations, things to think about. We just talked about scale. You should also keep in mind that event publications are non-transactional. We talked about that. And again, fire and forget. There isn't any feedback from the consumer to the publisher, and there's no rollback as well. So any type of failures, you're going to have to report on your own. I just mentioned separate transactions. So they're totally independent processes, so they're going to have their own governance limits as well. So the publisher had its governance limits as far as DML and SOCL statements and stuff like that, and so will the consumer. So that's another benefit to separating those two processes and connecting them through an event bus.
Okay, demo time. So I'm going to talk you through the basics of what we're going to show you, and there's going to be some audience participation. So if you want to have your phone out, if you are feeling in a participatory frame of mind. So Larry and I have decided to form a startup, and we are getting volunteer space cadets to the moon. That's our idea. We figured, there seems to be an opening in the market right now. We might be able to get in there and take over the current front runner. And why not? Who better than two Salesforce developers to launch a space program? I think it's going to be great. The first thing we need to do is get some candidates in the door. So we're going around to events, and we figured maybe a phone number that people could just text into, and then we could get that into Salesforce, and then we could get the ball rolling. We're doing this really fast. We don't really know what we're doing, and we're probably going to change our mind a lot. So we wanted to take a microservice kind of approach because I want to have some building blocks, like I know the basics, but I'm going to change my mind a whole bunch down the line. So as flexible and as swappable as I can make this, the better. So the basic setup is we got a phone number from Twilio, which is just a programmatic SMS service. You can sign up by a phone number, people can text in, and then you can have it do stuff with it programmatically. So I've set up a webhook in Salesforce, so every time somebody sends in a text, hits my webhook. And here's where maybe typically I would then, insert a lead or call a class that does something like that for me. But I don't want to tie myself to that model right now, and I don't want to have to come back in and touch this code. So I'm going to have that webhook, call an interface so that I can just publish a platform event. And then I can figure out what I want to do with that later, and I can change my mind as many times as I want without changing the code. So after that event gets fired, now we've got our event bus. And so out of the gate, I was like, well, maybe process builder. I think I want to create some leads. Let's just start with that. So completely declaratively, I have process builder subscribed to that platform event, and it's going to go in and it's going to create leads every time that text comes in. And maybe a couple weeks later, we realize, we need to be able to enter these, just for somebody who's working within our system as well. They could just go in and create a lead, but I don't really want to tie it to leads again. So why don't I create a flow? And so I created a flow where a user can enter Cadet information, and instead of that inserting the lead directly, it fires the same platform event, and that means that process builder is going to pick that one up just like it picked up the text and do the same operation. A few weeks later, we're like, we should probably have a website. Seems like a good idea. So we build a little website on Heroku. Again, there's a web form. They fill it out, and what does it do? It fires a platform event. So same pattern, but coming in from an external system, and still my process builder's just doing what it does because it's listening to that platform event. And it doesn't matter that it came from Heroku or Flow. It's going to work the same. And in 2 weeks, when we decide, actually, maybe we should create contacts, or you know what, a custom object would be much better. All I have to do is go into my process builder and update it there. I don't have to touch any of these other integration points, and that's pretty cool. So we've got a phone number up on the screen. If you feel so inclined and you want to go to the moon, text in your first name and last name, or a pseudonym, be nice, to that number, and we'll pull that up in just 1 second. So the next thing I'm going to show you is a Lightning page that Larry built that is also a consumer of this platform event bus. And so all we did is we're having it listen and display those names and numbers as they're rolling in, just to give you an idea of what that looks like. Beautiful.
So,
oh no!
one.
Live demo! Oh God, we didn't make a sacrifice to the demo gods. It worked 10 minutes ago. Oh, I'm so sad. Okay, if anybody else wants to send in a couple more and save us, their phone number's up there. See if it'll come in. Oh, this is crushing my heart. Yes, Captain Awesome, thank you. Apparently having a different context open was not listening. And so that actually points out how ephemeral this is, right? Because this is not showing you the leads that were created. This is just showing you the platform events as they're coming in. So these have not been saved anywhere. It's just listening and putting them on the screen. Some other process has to grab these and actually do something with the data. This is just purely a listener. Awesome, thank you guys. That was really helpful. All right, so let's take a look at a little bit of the code here. If I can use this machine. Larry's one of those deranged individuals who
Everything's backwards.
reverses all of the swipe motions. So I have to reverse my brain around in order to do this. We'll see if I can do it. Okay, so first thing I'm going to pull up is the Twilio webhook. And I won't talk through too much of this code in detail. It's, I know it's kind of tedious and hard in a live demo to really consume. But the important point is just, you can see I've got just a nice little endpoint here for my Twilio event. And I'm unpacking the data that Twilio sent in, which is really just the body of the text and the phone number. And then I'm just formatting it because I need to pass it into my platform event generator class, which is, of course, bulkified and somewhat generic. So I'm just packing these into maps of field names and values so that I can pass it off to the platform event generator down here on line 65. And that's really all that's doing. And this is our nice bulkified generic platform event generator. So it's taking in the object name, which in this case is the name of the event. And then it's taking in a list of field maps so that it can create an event for each one of these. When you're dealing with platform events in Apex, you'll see that they're treated very, very similarly to S-objects. All the syntax is the same. I mean, obviously, there are other things that you can do with them. But you can see I'm using like schema object type to get, to use that object name to actually get the event object itself so that I can fire it. And then I'm unpacking that data, putting it into those fields. And then down here on line 28 is where we've got our event.bus.publish. And then we give it a list of events to fire. So once that line executes, line 28, we're in a new context. So we've now launched an asynchronous process that's happening over here in its own execution context. These are now completely separate processes. We get this database save result that we can iterate through just to interrogate and see, oh, this actually worked. We were able to fire. But we're not going to have any idea if our downstream consumers picked it up or if there was an issue down the line. All that complexity is going to be handled further on down the line in that other transaction. And then I think I'm going to pass it back to Larry, who can actually like that. And he's going to show some of the declarative stuff.
We're going to start out with the Visualforce page first. So this is the Lightning bundle. This is the view part. And I don't want to go through all the code, but notice on line 2 and line 3. So line 2 has a reference to the Comet D static resource.
Can you do? I should have done that too.
Is that good? So the Comet D resource that's currently in static resources, that will be replaced, at least in Lightning, with new tools with the next release. Line 3 has the session ID. That's being received from a class. We didn't go into that class because it's just 3 lines that send back the session ID. And then this is the controller. The controller really, I'm not going to go into details because what I really want to show you is it passes through to the helper, and the real connection of the Comet D is here in the helper itself. So at the top, it's connecting the Comet D. It's setting some different settings, and then down on line 9 is where we're using the session ID. And down on line 20 is where we're actually subscribing. So text to lead is what we named our platform event. And then further down on receive of notification. So anytime that there's a platform event, this is what receives it on the Visualforce page and dissects it, assigns it to the last name, first name, and displays it on the page. Okay? Then back over here, so we'll look at some of the declarative tools real quickly. So in Process Builder, it's really rather simple. We create a link in the Process Builder to the event itself. Again, text to lead is the event. And then in our case, we're associating our leads to an account called Salesforce. So we created this criteria here to just make sure that the account exists. And then down here where we're setting criteria in this place, in this part of the process, we don't really want to do anything. We don't want any decisions, so we're just passing through this. So we took the bottom button. I don't know if you can see it. I can barely see it on mine. But we took the bottom there, no criteria, just execute the action. And then we go over to the action itself, and we're creating the lead. So record type, lead, and we're associating the lead field. In this case, I'm just hard coding Salesforce, and the last name to the event reference last name. So just mapping those fields, and that's all it takes for the Process Builder. So what this Process Builder has been doing as we were demoing is creating leads. So you can see here that all of your leads that you sent in are now going to be considered as part of our Salesforce Cadet. All right, the last thing I want to, or is it the last thing? Second to the last thing. So we also wanted a way, Melissa mentioned, we wanted a way for our users to also be able to enter cadets. So they may be answering the phone, taking cadets' names over the phone. So we have this process as well. Let's see if it errors out. So if we come back over here to, we should see John Doe. So just another entry point. I won't go through making a flow because we're coming close to the end, but we also created this Heroku app. So this is actually the Heroku app that is used in the Bearwatch Trailhead module. So Philippe created this, and we just took it from his GitHub repository and just repurposed it for this, reskinned it. So this is fully on Heroku using Comet D, sending or publishing events back to Salesforce. So
it was mostly just so that I could use that Astro the entire demo, because I really like that Astro.
I haven't refreshed this page, so hopefully it's working.
Yeah, we did not do a good job of making our ritual sacrifices to the demo god. My mistake.
So I'm going to refresh the page.
He's lost in space.
There it is.
You can tell we're front-end developers, right?
Yeah. So down here, so these are the leads. There I am at the bottom.
There it is.
So through Heroku, we can do the same type of thing. That was just publishing. The next step for us, I think, is making it work for subscription. So that, that's it for the demo. Back to the slides, if I can find them. All right, recap. We covered microservices and event-driven architecture and how it allows us to decouple those processes and make those services totally independent and isolated, and then put them together again as blocks, either through code or through tools, declarative tools such as Process Builder. And then platform events. This helps, along with other things, to make those microservices work. So Salesforce is starting to incorporate this more and more, and I think we're going to see this over the next several releases, just a lot more ability to use platform events as well as other tools on the, from that perspective. And keep in mind that Salesforce is not a microservice architecture in itself, but it can easily be manipulated and used in such a way that it acts as one. So you can take the advantage of some of the microservices concepts for testing, as what excited me the most, as well as other things such as plug and play and just putting things together and making it easier to take those blocks, repurpose them, and refactor them and put them back in. And our call to action slide. So these are some of the links that some of the resources we used for this application and this presentation. 2 Trailhead modules. Those were really, really good for helping me get started. And we used some of the information from there for the basis of this. GitHub repos. We've got our GitHub repo in here that has a lot of the base code. And I wanted to call out that Philippe's code for the Heroku page is in here as well. And then some other links to take a look at. Bob Buzzard is one of the, he's got a great blog to check out, and he's referencing some of this stuff as well. All right.
Awesome. Well, we've got just a couple minutes. If anybody has questions, I've got swag. Can you come up and use the mic just so it's on the recording?
Hi there. Yeah, I really like what your presentation was and everything. And I had a question. With the event system and everything like that, are there any limitations with it? I mean, you talked about API limits and everything like that, but in terms of field limits or any kind of restrictions in that regard to the event system, anything like that we should be aware of?
In terms of if you're talking about how many fields can you create, we were looking into some of those, and I don't even think we got a direct answer, but they're set up in a very similar way to S objects when you go into setup, and so my hunch is that it would be the same limitations that you would have with any S object. I could be wrong, and if anybody knows, correct me if I'm wrong, but I believe those same limits would apply.
Thank you.
So a lot of your examples were based on UI interactions. Have you run into problems where things will fail midway through if you have a multi-step process, or how are you returning failures back to the user in UI context?
That's a good point. We didn't get into that level with this kind of demo code, but error handling is a really important part because of the asynchronicity of these. So it's one of those things where you have to be catching every step along the way of that asynchronous process so that you can wrap it up and say, okay, there was a failure here, and that you can log it. I mean, for me, those kinds of processes, it always comes back to logging those errors so that I can have a secondary process that's going in and reading through and then handling it secondarily. But yeah, that's a challenge we didn't really get into.
From the Apex perspective, the after insert trigger, like I did mention, that has a way to look at the results. So you loop through them just like you would loop through the DML results.
Yeah, so you can know that the message saved, but you don't know that the consumers did an error out.
Right.
Right,
Yeah,
absolutely. It's a totally different transaction. And on the consumer side, you would have to do something with it. You would have to throw it into another object and list the error, or you'd have to send a message out, something like that, throw it into chatter. But yes, there's no interaction between the two. You have to find a way to recover.
Great, thank you.
One more question? Socks or things?
Hi there. Thanks a lot for the presentation. That was great. My question is, given that Salesforce supports bulkification, and my question is, how do you suggest using platform event in conjunction with that bulkification? And can we use it? I mean, is it good to use platform event if we want to support it? Or?
Yeah, you can handle bulk events you can fire off lots and lots of platform events. I mean, we put the limitation slide up there, but the platform events generator that I pulled up will take basically a list. So it'll fire as many as are needed for that context. Is that what you're getting at?
Yeah, so for example, like if a single record gets updated multiple times, and you want to, first of all, you want to combine them and make just one DML because DMLs are expensive. That's one thing. The other thing is if you update multiple records in one transaction, then how would you suggest to create platform event records for each one of the records are
It would
updated,
depend on
or
your
just be
use
combined?
case. I think I'm not quite getting what you're getting at, and I think it's me because I'm nervous.
So are you trying to say you're updating several records, and then you want to take those records that you updated and somehow publish a platform event based on, let's say there's 5 records you changed, send off one platform event for those 5 changes?
Right. So say you have order and order details. So you update 100 order details.
Yeah, let's chat. And if anybody else wants to come up and ask a question, I've got more swag. Thank you so much for coming out. Hope it was helpful.